In this video, we're going to generate toolpaths on the vectors that we created in the first part of this tutorial where we did the design work. We're going to start by doing a simple V-carve toolpath to engrave the decoration into the top of the panel. Then we're going to show you how you can set up a special shaped cutter, in this case the raised panel OG shape, and how we can add that to the tool database within the software. We're then going to generate a profile cut around the outside shape of our panel in order to create that nice flowing raised panel shape that you can see on the screen here. So let's start a new copy of the software. So let's go ahead and open the file that we created in the vector layout part of this tutorial. Now click on the open existing file option. And from within the project folder, we're going to load the file cabinet door vector.crv. Hit open. So there we can see the design we created. And first operation I'd like to do here is to calculate the V-carving on the top of our panel. So we're just going to select all the data we've got here, and I'm actually just going to group this together. So I'm just going to hit G on the keyboard to group that, and that will just make it easy now for me to select that with just one click without having to worry about picking up anything else. I know that all those vectors are going to be V-carved, so that's just a nice way of keeping this organized. I'm going to come over to the Toolpaths tab. So I'm going to click on the icon here to switch to Toolpaths tab. Shortcut key for that would actually be F12 on the keyboard. And F11, if you wanted to learn the shortcut keys, would take you back to the drawing tab. So I'll just demonstrate that. If I hit F11, it opens the drawing tab and closes the Toolpath tab. Hit F12, then it opens the Toolpath tab and closes the drawing tab. So with our V-carve vectors selected, we're going to come over, and first thing we're going to do before we calculate a toolpath is to set up the material, or check our material setup. So I'm going to click on the set button here, and the Z0 set to the top of the block, which is correct. 0.75, 3/4 of an inch is the correct thickness. For drawing, or for layout, I had the datum set in the middle of the part. Now we're coming to machine it, I'd actually like to set the datum to the lower left hand corner of my material. So that now where the red square is here in the lower left part of the white area, that's now going to be X0, Y0. So we've just changed that there. We're going to check the rapid gaps in here for the clearance and plunge, and the start position we'll enter a value of 1/2 inch. So we can go ahead now and hit OK once we're happy with that. Making sure we've still got our V-carving vectors selected. I'm going to click on the icon to go into the V-carve toolpath. So we're going to do a nice simple V-carve in this case. We're going to machine this right into the top of the panel, so start depth will be 0. The tool was going to be a 90-degree V-bit. We already have that selected. However, we could hit select and go into the tool database and pick that, and then just check the parameters. If we're happy with them, we can hit OK. Of course, if you are planning to machine this yourself, you need to make sure that you pick appropriate values, parameters, tooling, and everything that will be safe and will work for the material and your particular setup and your machine. Because this is just a simple V-carve, no flat area clearance tool required, we can just come down to the bottom, and I'm going to enter a name V-carve decoration, hit calculate. We've come into the preview toolpaths. We can select whatever material we'd like to use. I'll just leave it on the oak medium choice there, and then we can go ahead and click on the button to preview selected toolpath. I can see we have the tool switched on to animate and draw at the moment, which is why we saw that in the preview there. So happy with the way that looks for my V-carving. So we're going to go back to the 2D view. And the next thing I want to do is set up the tooling so that we can do our profile cut around the outside border shape and create our OG profile. So I'm going to close the preview toolpaths form there. So the tool that we're going to use for cutting the border shape around our raised panel is a specialty tool that's been designed specifically for that job, and it has a special OG profile. Any time that we want to use a tool that doesn't fit one of the standard configurations that we have in the software, such as ball nose or radius end mill, V-bit, those type of things, then we'll need to specify it by drawing a vector that represents part of the profile of the tool. Now you can either draw that straight within the software here, or it may be, as with many tooling manufacturers, that you're able to get a profile in a vector format from their website. A lot of tooling manufacturers that do specialty tools might provide a DXF or an EPS, which is the outline of the tool, to help you specify the geometry in a CAD package. So I have a vector that represents the tool we're going to use. So I'm going to come up to File and Import and say Import Vectors, and from the project folder I'm going to choose the file RPOG, that stands for Raised Panel OG.eps, and hit Open. Now I can see at the bottom left hand corner where my tool has been imported into here. To make it a little easier to work with, what I'm going to do is just go back across to the Drawing tab. So I'm going to hit F11 on the keyboard, and under the Layer Manager, I'm going to come under here, I'm going to right mouse click over this layer name, and I'm just going to say that I want to show only this. So what that's going to do is undraw the other layers, leaving me with just a layer that has the tool on it drawn. And if you remember from the drawing part of this particular tutorial, when we import something it will be automatically put onto its own layer. So that's why we had that layer which was created by the software when we imported it. So I'm going to hit close on this. To make it a little easier to work with, I'm going to center it in the middle of the part. So I'll make sure it's selected and hit F9 on the keyboard, which is the shortcut key to center anything I've got selected in the middle of my work area. Now if we zoom in here, you can see the profile of the tool. It's quite a wide tool that's designed to cut this kind of flowing OG shape into the side of our raised panel. But the only part of this that we need when we specify the tool in the tool database is just the right hand side, without the rest of it being closed in. So we're going to need to edit this vector before we can use it to define our form tool. So let's click on the vector to reselect it. I'm going to go into node editing mode. I could come over to the icon here, or we could hit N on the keyboard, the shortcut key. There I can see the individual constituent parts of my vector, and I can make edits to them. As I move the cursor over the different parts of the vector, it changes to show me I'm either over a node, or in this case when I see that little wave, that I'm over a span. What I want to do is delete this top span to open this vector up. So I'm going to right mouse click on there, go down to delete span. And then for this middle one, I want to divide this in two. So I'm going to drag a little selection box around the virtual midpoint so it's selected and shows up in red. And then I'm going to right mouse click on that and go down to cut vector. That's now divided this in half, so I can click on this side and hit delete in order to get rid of that left hand side part of our tool shape. Now I'm going to come out of node editing mode. So notice the cursor at the moment, that type of arrow is showing me I'm in node editing mode. If I hit escape on the keyboard, then that exits node editing mode, and now I'm back into regular selection mode, and you can see that the arrow's changed. So now we have the piece of geometry that we're going to need in order to define a custom tool within the software. Essentially the right hand side of the tool profile with no top and no left hand edge on it. You need to make sure that you have this vector selected, and it's the only selected vector when we go into the tool database and we go ahead and tell the software to generate a new tool. So I have that selected. I'm going to hit F12 on the keyboard, which is the shortcut key to come across to the toolpaths tab. I'm going to click on the display tool database icon. Remember that vector's selected, and now what I'm going to do is come down and say that I want to create my new form tool in my specialist area of the tool database. You can put it anywhere, you can organize your tools however it makes sense to you. Here I'm going to put it in that area, and I'm going to click on the button that says new, And from the tool type drop down, I'm going to choose the option form tool. And as long as I have a valid vector selected, when I click on that, the software will automatically populate the information inside of the tool database. So from the selected vector, you can see the software has created a little avatar here to show us what the shape looks like, and it's picked up the size of that vector to give us the diameter of the tool. The top here, it's also given us automatically a name that's says form tool and that size. If we wanted to, we could come in here and we could change the name of the tool. I just missed an E out there, so raised panel OG in this case. And then what you do is look at the tooling manufacturer's suggested settings in order to populate the rest of the information in here. So I may come down and say that we're going to run pass depth of 0.2 of an inch, step over 1. We're not really going to be stepping over with this because we're unlikely to do a sort of pocketing or raster style toolpath. So pass depth is important though in there. Spindle speed, feed and plunge. So we're going to enter values that would be appropriate for the material we were cutting. An appropriate tool number if we had a tool holder. Hit apply. That's now been added to my list, you can see under this specialist area, and that will always be available to me from the tool database from now on. Here I'm just going to hit OK, and now we're ready to switch on our geometry again and actually calculate the toolpath using that tool that we've just added. So let's hit F on the keyboard to fit the job setup area into our window. I'm going to go back over to our drawing tab, so I'm going to hit F11 on the keyboard, and from the drop down layer list I'm going to undisplay import RPOG, so I'm going to click on the light bulb so that's not displayed, and I'm just going to switch on our layer 1, which is the data that the layer that we've got that's got our two vectors on it for the outline, and we'll select layer 1 as our current layer in case we create anything new. So let's go ahead and hit close. So when we did our design layout, we'd created the outside shape for our door, and then we'd offset this vector by 1 3/8 of an inch. And the value of 1 3/8 of an inch was specifically got from the information of the tooling manufacturer, who suggested that that is the width that you're expected to cut the OG with that particular tool. So essentially we took our outline, we've offset it inwards by the value that was recommended, and we're going to profile around this inner edge in order to create our OG cut. So I need to select this inner vector. I'm going to hit F12 on the keyboard to go back to the toolpath tab. I'm going to go into the profile toolpath. Within here I want a start depth of 0 and cut depth is going to be 1/2 inch. Again, this is information from the tooling manufacturer of how deep you're expected to cut with that particular tool. We're going to hit select on the tool database, and we're going to choose from the specialist area the raised panel OG tool. So we could check our parameters there, I'm happy with them, I've just set that up so that's okay. We want to cut outside of this vector. We want the edge of the tool to run around this. That's why we offset it by that distance. So I'm going to change the name to Profile OG, hit Calculate, and we're going to preview that toolpath now. So there's a couple of things that we should notice from the preview here. One is that with such a wide tool, that part of the tool is cutting past the edge of the job. I'd need to be sure that anything I had around this material, clamps or other material, was not going to be right next to that edge there and would have enough clearance for that to miss it, or I would want to come in here and change the size of my material or change some of the parameters to adjust that. So that's one thing to be aware of. For this particular example, I'm not going to worry about that. The other thing I can notice is the corners. As this has cut around the sharp corner of the vector, it has rolled around, which is the default behavior for the software when it's profiling. In most cases, when you're, for instance, cutting something out, then you don't really see any issue with that because it just comes here, cuts here, and you get a nice square edge. When you're using a shaped tool like this, though, because it's rolling around, it's rounding that corner. Now the chances are we probably want that to have a more like a mitre look corner to it. So what we may want to do is just undo the last preview here. So if I click on the undo last button, that will get rid of the preview of our OG toolpath. And then I'm going to come down to the toolpath list and I'm going to double click to go in and edit that toolpath. And how we stop it from rolling around the corners like that is to come down to the corners area here and to check the option that says sharp external corners. So now what the software is going to do is bring the tool all the way past and then take a right angle instead of it curving and rolling around that corner. So if we hit calculate, we can see the new toolpath we've created there, but really the best way we're going to see this is to go ahead and say preview selected toolpath. And there we can see that cutting around the part, and now we've got these nice square corners on the top and bottom of our panel. So our final task is to create the profile cut for our raised panel. I'm going to come back to the 2D view, I'm going to select the outer vector, I'm going to close the preview toolpath menu that we're in there and click on the profile toolpath again. Now this time I want to cut all the way through the material, so I'm going to put in 0.75. Need to hit select, change the tool to a standard 1/4 inch M mill, 0.25 M mill, hit OK. And I'm going to just edit that and tell it that I'm going to cut 1/4 inch on each pass, so that will change the passes to 3 instead of 6. Need to make sure we're cutting on the outside of this part, which is what I've got there. And we'll call this profile cutout, hit calculate, and then if we preview that toolpath we can see that cutting through the outside there. And if we want to, we could double click on this waste material with the mouse. So if I just put the cursor over the bit that I want to get rid of and double click, then that will delete that and it will show me without the waste material there around it. If you wanted to, you can use the button here to save the preview image. You just tilt it around using the left mouse key into a view that you're happy with. You can hold both mouse button down and move the mouse to pan it, or you can use the right mouse button and move the mouse in order to zoom in and out on it. When you've got it in a view that you're happy with, we could click on this Save Preview Image button, and that would allow us to save various image types, and we could use that for customer approval or promotional material, putting on your website, something like that, in order to demonstrate what you can do. So the last job with this, of course, if we close the preview toolpaths, would be to save our toolpaths and send them to the CNC. So we'd choose them in the order we wanted to output, hit the Save Toolpaths icon, go ahead and choose the right post processor, click on Save Toolpaths in order to save, give that a file name, save the first one, then we'd select the second one and hit save, then select the third one and hit save, and give each of those a name, and be able to then put them onto the CNC machine and cut your raised panel. So before we conclude this, we should save this file so that we have a copy of it in the projects folder. Come up to File and Save As, and we'll call this Cabinet Door TP to show that we've got toolpaths in it, .crv, and that'll be saved there if you wanted to take a look at it. So let's close the Save Toolpaths form there. Just take a moment to review some of the things we've looked at in this video. We started with the file that we created in the companion tutorial to this, where we did our vector layout. Went ahead and calculated a simple V-carving toolpath to put our decoration on top of the panel. Then we imported some vector geometry that represented the profile of our tool. We then used that with a little bit of editing to create a form tool, a special shape tool that we can select within the software, and then calculated a profile toolpath around a vector that we'd offset to allow for the width of the tool and how much we wanted to cut. When we previewed it, we saw that the tool was rolling around the corners, and so we went back in and edited the toolpath and chose the square corners option so that we'd get it to create the nice kind of mitre effect of the corners that we can see on the door here. And that concludes this tutorial.